Lots of people went wrong. I got something that gets rid of milliliters right here. Milliliters to grams. And so this is, I got 1.03 grams for every milliliter. Oh, milliliters cancels milliliters.
Well, isn't that milliliters seawater and then grams would be NaCl? So you're introducing a new factor, even though, because I mean it's 1 milliliter of seawater, which is also equivalent to the 1 milliliter of seawater, but it would be grams, it would be NaCl. So you cancel your seawater, but you're introducing NaCl.
Would you agree, you guys, everything?
Yes.
Yeah? Okay. What is density? So for example, what is the density of water? 1 gram of water per milliliter of what? What is the density of gold? 1 gram of gold per milliliter of what? Per milliliter of seawater? Is the density of gold 1 gram? Oh, no, it's not 1, it's 20. Is the density of gold 20 grams of gold per milliliter of seawater? Is that it? No. This is why I said we got to be very careful here, because this is 1.03 grams of sodium chloride per milliliter. Oh, actually, this is not. This is seawater. Sorry. Seawater. Per milliliter of seawater. Oops. I didn't read the problem correctly. Did I do that? Yeah. 3.5%. Okay, I'm sorry. You know what? I misread this. I misread the question. This is correct. This is milliliters of seawater canceled out milliliters of seawater. This would be grams of seawater. That gives us grams of seawater here. And then what? But not grams of sodium chloride. This gives us grams of seawater. And then what? Yeah, we have this one, 3.5%. So what is the 3.5%?
Grams of NaCl.
This is 3.5% NaCl by mass in seawater. So if it's 3.5% NaCl by mass in seawater, then that means it's 3.5 parts out of 100 parts. It's by mass, so we could use any mass unit we want in here. So we could use 3.5 pounds per 100 pounds, or we could use 3.5 grams per 100 grams. So which one should we use?
Grams.
We should use grams, so 3.5 grams per 100 grams. Now we have to define what? 3.5 grams of what per 100 grams?
So it's
This is going to be 3.5 grams of pure sodium chloride per 100 grams of,
salt water.
yeah, of seawater. All right, so then, well, actually we need to get rid of grams, or we need to get rid of grams of seawater. And so here we got rid of milliliters of seawater. Now we're at grams of seawater. And so we're either going to get rid of grams or grams of seawater. Well, we can get rid of grams of seawater right here. It is for every 100 grams of seawater, there is 3.5 grams of sodium chloride. And so this would be pure sodium chloride. So now the grams of seawater cancel out the grams of seawater, and we're left with grams of pure sodium chloride. And then from the grams of pure sodium chloride, we're going to go, well, we got to get rid of that. We're either going to get rid of grams, or we're going to get rid of grams of sodium chloride. Well, we aren't going to get rid of grams of sodium chloride because we just used it, our relationship there. So we're going to get rid of grams. So we can go from grams to what? Here. So we'll go from grams to pounds. So 453.6 grams for every pound. And so that gives us pounds of sodium chloride, and then from pounds of sodium chloride we go to, this is actually, you guys know the formula for sodium chloride? Nice. And then we're going to go to tons. And so this is 2,000 pounds per ton, and then this should give us tons of sodium chloride. And so let's punch this out. Here I'll have 300 million times 5280 cubed times 12 cubed times 2.54 cubed times 1.03 times 3.5 divided by 100. I got, divided by 100, divided by 453.6, 453.6, divided by 2,000. I got 4.96. So it looks like we're allowed 2 sig figs because of the 3.5%. Also the 330 million. There's probably 2 sig figs here. So it looks like we're allowed 2 sig figs, so I'll carry 1 extra. And so I'm going to go 4.96 times 10 to the 16 tons. Okay. All right, so this is what I get for tons. Now, I don't know, did I get the right answer or did I not get the right answer?
Wouldn't it just be 5.0 times 10 to the 16?
I rounded it.
Yeah, you would round it. I mean, I have it. I always carry 1 extra digit. This is what I want you guys to do too, because I want you to show me the drop digit. Yeah, but you would round it to 5.0. But what I'd like you to do is write the 1 extra and then show me the drop digit. This is what the book doesn't do. It doesn't show me the drop digit, but this would be rounded to 5.0 times 10 to the 16 tons. Now let's see what you guys got. You know, looking at this, $5.45. 5.5. Okay, a lot of people got 5.5 times 10 to the 16. A lot. And so the thing is, do I know, if most people are getting 5.5 and I'm getting 4.96 or 5.0, am I doing it right? Or are you doing it right? Am I doing it wrong? And so this is what I do, because I don't have the answer. I can't look at this up in the solutions guide. And so what you do is you just re-punch it in your calculator. Maybe I miskeyed it in my calculator, right? That's possible. I check to see, does it make sense? Well, it's got to be a huge number, so it kind of makes sense there. But other than that, once I double check it on my calculator and I just look, the units work out, the numbers appear to work out, then it looks right to me. And that's all I'm going to leave it at. If I double check the calculation, I get the same answer, I'm going with it. I'm going to say that's the right answer. And so this is what I do. Anyway, if you're getting a different number, I would re-punch it in here. So normally, and this is something I don't know if I mentioned, but in the afternoon class, somebody asked me, how much time do I give on the test? And there are two. Like when I was at UCLA, we never had enough time. There were too many problems, not enough time. So you always left problems blank, and so you always look for the easiest problems to solve first. That way, you can make more effective use. But for your test, you're going to have plenty of time. You're going to have plenty of time to go back. Well, you should have plenty of time to go back and double check your answer. And so, you know, everybody should rekey it in their calculator, because a lot of people, what they do is they have the setup right. And the setup is going to be worth 90% of the points anyway, but they have the setup right, but they miskeyed it in their calculator. And that was the only mistake. For some instructors, the wrong answer is wrong answer. They don't care, because, you know, if you miskey it in your calculator and you're calculating the dose of medication, then, you know, your patient could die, even though the setup was right. And so some instructors here give 0 partial credit. You know, it's either right or wrong, even if the setup is correct. But anyway, we'll do this again. 330 million. I'm going to use this calculator this time, times 5280, because my phone is hard to tell. But if most people are getting it, then I probably miskeyed it. Times 12 cubed times 2.54 cubed times 1.03 times 3.5 divided by 100 divided by 453.6 divided by 2,000. Okay, then when I redo it on my calculator, I got this. I got a different answer than this one. When I redo it on this calculator, I got 5.46 times 10 to the 16 tons, right? And so if I got two different answers, then I do it a third time just to make sure, right? And then this is called this is how science is checked. Science is checked by a peer review process, you know. And this is what we had in this room. This is why I didn't care if you worked with other people. Otherwise, I'd have you work alone and individually do it for me, right? So this is 5.5. Well, the test, you're going to be working alone. You can't work with a partner on the test, right? But on these quizzes, this is a low-key quiz, like I said, times 10 to the 16 tons. That's why I don't care if you could solve. All right, so this answer is in agreement with most people here, and then, you know, we can be pretty confident that this is the correct answer. Now, does it mean it is the absolute correct answer? No. Sometimes people do this, and then there's certain rescissions and certain things get published, and then they realize, oh, there's a mistake. Or things get published, and they realize that the authors made a mistake. And so what happens in science sometimes is that people will come up with something called a reevaluation or a reinterpretation of so-and-so's data. Right. How late do we go till today? 35? All right.
To revisit my question before, can you produce a list of all the measurements used, like on Piazza or something? Just so we all
Well,
have different lists.
did you catch the list?
Yeah. But I just wanted a physical list so it's tangible in the future, not just a verbal.
Okay. The physical list is in the Chem 4 supplement. If you look, there's a memorization list in there. I didn't put it out. But it's in your supplement, and I'll show it to you. I'll show you what pages. It's there. There's a list of not only constants to memorize, there's a list of elements to memorize, which is more than what I gave you initially, but eventually you're going to have all those elements memorized. Eventually you're going to have all those constants memorized. That's the complete list of constants to memorize. It's on the list there. The Chem 4 supplement, I don't have it with me, but I can show it to you tomorrow. All right, well, that's that. We still have a little bit of time, so you know what I want you to do? See if you could do this one. 73. Actually, not 70. 1.4 grams of magnesium. Yeah, see if you could do number 73. That's not the density, actually. At the end, this, we don't have to, they're gonna say assume a density of this. 1.025 is what they're saying, the density. Obviously, the density varies a lot more than that, you know. That's quite precise for a density, 1.025, but we'll just go with it. This is, we wouldn't call this a density. You know what we'd call this? 1.4 grams of magnesium per kilogram of seawater. We wouldn't call that a density. We would call that a composition. And this is a composition that's kind of funky because it doesn't fit like the part per million. This would be a part per thousand. So this is 1.4 part, actually per kilogram. So it'd actually be, it'd be a little bit more tricky. So 1.4 grams, a kilogram is 1,000 grams. And so we would call this a part per thousand, actually. That is correct. It's part per thousand. But a part per thousand is a little bit tricky because it would be, you call it BPT, but BPT is already used for part per trillion. And so part per thousand, they just probably write it like this, or they'd write it like this. A pp 1,000, part per thousand, or pp, maybe a th instead. But a ppt is part per trillion. And so in this case, they wrote it out for you rather than give you the unit. So try it and see, you know, see if you can do it. You want to give it a try or not? Let's try it. When I was talking about habits, I did the same thing. I would check my answer in the solutions guide. So I never really double check. Like on tests, you know, you can catch simple mistakes by double checking. And then I'm checking for reasonableness of the answer. And so I never really developed that skill initially, and not until much later. But if we start off at the beginning, you know, obviously, yes, we could check the answer in the back of the book. That's always good. But we need to start thinking about how we can check the answer without having the answer in the back of the book, especially on tests. So is somebody getting stuck? They need a hint? All right, how about this? You know, we're coming to the end here. Why don't you try to finish this at home? See if you can finish it. Otherwise, if you're close, just stay and then see what you get. We're done at 35, yeah. You still have a few more minutes. If you could get it done.
Oh, so you just, it's on top and bottom.
Right, it's 20 grams of gold per milliliter of what? You know, so it's seawater. Yeah, this gives us cubic centimeters, but they want cubic meters. Not cubic, yeah. It's correct up to there. That's the same thing, you're correct up to there. It's just this. Other than that.
But right here, would you, this is a conversion factor.
Okay, this one is not specific for seawater. This one can be for anything.
Oh, so you don't need the...
You don't need seawater on this one.
Oh.
This one you need seawater because this only works for seawater. If
Right.
this is not seawater, it fails. This one works for anything.
Oh, because then the centrifuge
This-
cube of seawater goes, that comes over. Oh, that
Yeah,
makes
the
sense.
seawater just carries over.
Right. Okay.
And so this is why, like, so this is what And so, yeah, it didn't cancel out, so you carried over. And then you just need to
Makes a lot of
out.
I still got a, yeah, I should do the process, but it looks like, I'm pretty sure this should. Yeah, that's how I didn't guess that, but I got the wrong. You need this last time. This last step is it